So we already saw value types and reference types. A value type is a native data type, and once again, if I can draw the structure of RAM, right, the value types are going to get declared over here. So when I say integer I assigned to 10, integer is a value type, and it is going to get 4 bytes of space inside this RAM, this part of RAM, and it is going to save a 10 here. But types, reference types, they are a little different. So if I have a class for customer, and if I declare an object of that, the variable C itself, it is going to get declared over here. So the 4 bytes of memory, there's definitely going to be more, but then let's assume 4. The 4 bytes of memory where C is going to get stored will be from the stack. And say if the customer is a 100 byte object, those 100 bytes will be given from the data segment, right? And C is going to store this particular reference. Now if I create a new variable and say I call it D assigned to C, D itself is going to get additional 4 bytes, and once again, because it is declared within the scope of a block, D is going to come and sit here in the stack segment. But then because of this assignment statement here, it is also going to point to the same location, right? Because everything is pointing to this part here in the data, if I do any action on this d.name assigned to Sia, it is also going to affect the values in C, because they are both pointing to the same memory location. Let's quickly take an example of that to our C# class, and I'm simply going to add a new class, and I'm going to call it objects in C#. To declare a class, an easy way is that you type class and hit the tab key twice. It's going to give you this template, and I can say customer. And to declare a property inside this class, type prop and hit the tab key twice, string and name. Now I'm going to come and declare two variable. So let's introduce this var keyword. So the var keyword is a generic name for any data type that is on the right hand side. So let's just call it customer, right? If I hover over var, it is going to say that it is of type class, and it is giving me a fully qualified name, right? The namespace, then the console app, and then customer, which is actually this class here. So var assumes the exact type on the right hand side, and it can become very dangerous if you are expecting it to be an interface. So and you are assigning a class over here. So this is a tricky keyword, and the reason I was not explaining it to this point is because I want you to be very careful and aware. When we look at interfaces, I'm going to explain var in a little more detail, but then var is a syntactic sugar for not having to type a lot of class names, and then it is just going to assume that. Another example could be var I assigned to 10, and now if I hover over it, it is a struct of 10. It is integer 32, right? So var assumes a type on the right hand side, and you don't always have to specify the type itself. It can infer the type from the assignment also. So let's go ahead and do var d assigned to C, and if I do C dot name and then d dot name assigned to C here, probably this is going to complain at this point. So and now I'm modifying the name property to the variable d, and if I now print through C, So every time I'm using C for printing name, but then I'm modifying it using D. If I run this, I did not print any. Okay, I'll have to do a little more work. I forgot something. I'll have to use this class name in our program.cs, and once again it has assumed the right type, objects in C sharp, and we have the run function. Now if I hit Control F5, it is going to come here and print test first and then Zia later, which is establishing the fact that these two variables, they were referring to the same memory location, and then the effect that we're going to make on one, it is going to also going to get reflected on the other object. Okay, but there are other ways of declaring objects as well. We'll comment this one out, and then this is where var keyword is going to come in handy. If I want to declare a complex object, the concept of once again abstract data type, I don't always have to define a name. I can declare something in line, and probably I have to put a new keyword, and over here I can go about defining those values. So not a semicolon in the curly braces. So you start with a member name. You don't have to define its type. You just have to assign a value to it. So I created two things, and I'm going to say hello over here, probably in double quotes, like this. So depending on the data type on the right, it is going to assume that it is a string type, and I is going to be an integer type. Let's go ahead and print these values, and I, and then over here I'm going to say j, and if I run it without any surprises, we're going to see 10 and hello, which is the value of I and j variable. Let's go ahead and look at this code in the ILSpy. So I'm going to pick up this thing, launch ILSpy. Right, so this is the console app that we are working on, and in the metadata part, alright, I think this has something to do with .NET Core 5.0. Let me quickly launch a new version of Visual Studio. I'm going to copy this implementation, and paste it in the .NET Framework project. So I think that should fix it. So let's give it a run. I'll have to come and fix this thing a little. And then app.run is going to call that public function. If I run it now, alright, so we get the same output, 10 and hello. When you declare an object like this, if I hover on I, you're going to see a special syntax there. So let me just copy this, and let's talk about it on the whiteboard. So when you declare an object without a class name, directly with a new keyword, without specifying any type over here, C# internally generates a new class with this syntax here. It is going to have a little tick and then a dot and then you can refer different members, and then notice that it has a get property, and then it is saying that this is an anonymous type with this name, integer I and integer a. This is what the type looks like. uh, I was trying to show you the same thing in the ILSpy part as well, but then it does that to me sometimes. It has happened to me earlier as well, and I think I should be able to fix it. So like classes, we have an option of anonymous types, and we are going to heavily use it when we want to create a new projected type. I'm going to show that to you. Uh, so jumping back to our example from delegates, I'm going to add new class and call it delegate demo. Just a quick recap of what we did yesterday on delegate side. We had a function called add, and add is going to take two numbers, and it is going to return the sum of those two numbers. So if I take integer x and integer y here like this, and okay, I will not be able to return it, but let's just print it here, x plus y, right? If I want to declare a delegate for this particular function, all I have to do is copy this syntax, come outside the class name, and I'm going to paste it over here. And in front of this, I'm going to append the delegate keyword. Now notice when I added the word delegate here, the color of this function has changed and it looks a lot like class, because this is um, a definition of something. It is not a function anymore, it is a delegate, and we can create object of this delegate, and because we can create object, it makes sense to have the same color scheme applied to it so that you can make some sense out of it. I don't like giving it a generic a specific name. I like giving it uh, something more suitable. Because it is an arithmetic operation, I'm going to call it arithmetic, right? So declaring delegate is as simple as copying the function definition and appending the delegate keyword in front of it. Now, one of the things that I did not show you yesterday is delegates can arithmetically, I can initialize a delegate like this, right? So I've initialized delegate and I can call it with the same parameter 10, 20. Let's just comment this out. And now if I run the application, it is going to once again call the add function, and you're going to see this output. All right, I will have to make change in the program, right? Now if I run the program, we're going to get 30, which is 10 plus 20, the add function. The add function is getting called because we have defined a delegate which is assigned to the add function. We can do something very similar in the subtract function as well, where we subtract the value, and I can definitely assign the subtract function over here. This is going to work, but instead of assigning, I can do addition as well, right? So the first time I assign the add function to it, the second time I am adding the add function, the subtract function inside the arithmetic delegate. And now if I invoke the delegate and if I hit Control F5, all right. And now if I hit Control F5, we are going to get this result, 30 and minus 10, right? So delegates, they are a little more complex than function pointers. With function pointers, you don't have this flexibility. So as many functions as you want to invoke on a delegate, you can go ahead and add them to the chain, and the multiply function is going to multiply these values, and it is going to call all three, right? So delegate has this feature where you can go on adding multiple effects to you can call multiple functions by adding them to the object definition and invoking them all together at the same time with this one single call. When we invoke a function like this, let's say 10 and 20, what the run function is going to do is that when it encounters this instruction, it is going to issue a call to this, passing it value of 10 and 20, and this function is going to get executed. Now, when you're writing bigger applications, jumping around from one function to another is sometimes going to get very complicated, and you would probably want to do it in line. So let me go ahead and change this value. I'm going to assign 10 here, and instead of console.writeLine, I'm simply going to return the sum, the addition, and the result I'm going to save here like this. Now, there's a special syntax of defining this function right here alongside inside this function, and we have already seen it in JavaScript as well. So just for demonstration, if I run this code, I get 30, which is add functions output, 10 and 20 addition. All right, so the way it is supposed to be declared is, you start with the func keyword or the action keyword, and then you pass it the parameters that you would want to mention here. And then if it is an operation or arithmetic operation, you can mention operation here. And then because you are taking two input parameters for add x and y, you're going to mention x and y over here like this. And then you're going to draw an arrow, and you're going to perform the same operation that you were doing there in this. And once again, it is giving me an error. Okay, because it is returning a value, I cannot assign it to function, I guess. Only assignment integer x. So I have to change this to a function and for an integer keyword over here. Right. So let's just change these values to I and j. I'm going to pass I and j. All right. So it was complaining about an overlap between x and y. Right. So what we have done is the add function, which was taking two parameters. We have gone ahead and we have picked this thing up and pasted it on the left hand side. Then we draw an arrow, and anything that you wanted to do inside these curly braces, it can continue to go here. Because there is only one statement, you don't need curly braces, but then I can put curly braces here and return I plus j. Right? What this is going to return is a function that takes two parameters and it returns one parameter. Right? And then if you remember our discussion on func yesterday, this is definition of a delegate that takes two input parameters and return one parameter. So now to invoke this, I'll have to once again call it, let's just pass some different values this time, 20 and 40. So the way to invoke that now is by calling arrow function, and I'm going to call it addition, and addition, if I print the addition result, right, we are going to see 60. So it is about, so these are the arrow functions. An arrow function is almost like this function over here, defined in line, but then the syntax is a little tricky. You don't mention types, you draw an arrow, and then everything that goes inside the body goes inside these curly braces. If there's a single statement, you don't need return and curly braces. These are arrow functions. The place where they come in handy is when you want to perform a multiple operation on the same type repeatedly, and you don't want to jump around your code. You don't want to jump around multiple lines of code and then try to make references as to what is happening. So it kind of happens in line. There's a better example of this. I'm going to come here, comment this out, and define a delegate called multiply or square. So that function is going to take one integer parameter and it is going to multiply two numbers, right? I can so this becomes the arrow function. I can use it inside a while loop, something like this. So let's assign another func here. Integer because it's taking one parameter, integer because it is going to return an integer, and I'm going to call it square and assign it over here like this. Now I can drop these parentheses as well. And now if I declare an integer array, call it inputs, new array of 1, 2, 3, 4, 5. Integer array. And now if I run a for each loop on each item in the inputs collection, in the input collection, I can do something like this. CW item, right? And now if I run this program, what we have done is we have defined a delegate with an arrow function syntax. We have an array of 5 elements and we are looping through each of those 5 elements and we are calling the square function. And then it's going to print these squares on all 5 elements through this functionality. Right, so every time you call square, it's going to jump right up, and then you can see the definition right here alongside, and you won't have to jump around. The syntax is going to be pretty straightforward as well. Right. Right. Let's go ahead and talk about events for a while. So what we have seen in delegate is that delegate is a memory location, is a data type which is going to store functions inside and can store multiple functions at the same time. And when you invoke a variable for the delegate and pass it the parameters that these functions are going to take, it is going to invoke all these functions. Now these delegates, they can be applied to another concept called an event. An event is a special object which is going to get created, a special type which is going to get created using delegate, and then these events, they can be subscribed to by multiple classes. So a class C1, C2, they would want to perform certain action, do something based on this event happening. So a good example is when the doorbell rings, right? Something in your house, when it rings like this, you would want to go and open the door over here. Okay. Now, for this event to happen, somebody has to come and say press a button outside, and then when this button is pressed, it is going to buzz, and everybody in the house is going to get notified about something is happening. And then they all can take an action, or only one person can take an action. So that is the idea behind events. To implement that, we are going to create a couple of classes, and those classes, they're going to have special delegate syntax inside them. So the first event I'm going to call, say, a person who is the door. The person is going to um, ring a bell. I'm going to change this to public, and we are in the house. So I'm going to say family member, and family member is going to have a name, and they are going to handle an event. They're going to do something when somebody shows up at the door. So to start with the program for that application, we're going to say attend visitors. Once again, we're going to call the public function name as public void run. So let's go ahead and create two family member. Right. Let's have another member. I'm just going to repeat this. I press Control E, Control V to create a new member, and let's just create a visitor. What do we call it? A person is in house. Right. So person P is going to have this type, and the person P is going to ring the bell. Now, when the bell rings, they are supposed to do something, and for that we are going to use delegates and events. So the delegate itself is going to look like this. I'm going to leave it public void. So the delegate name is going to be bell rang, and it is not going to take any parameters. It has to be with the person who is going to raise the event. All right. So it is going to sit here. Now, when somebody is supposed to handle an event, they're supposed to have the intuitive knowledge of this particular member here. And the way to do that is we have to keep an object of the person with us over here. So the person is going to be this member here. I'm going to have to make it public. Right? And let's just shuffle a few things around. Let's just create this person first. And over here, I'm going to say m1.person is assigned to person P, this value here. I'm going to do the same thing for m2 as well, right? So they both have a reference to this particular member over here. Now, when somebody rings a bell, we're going to define a new function over here. We're going to call it on bell rang. We are simply going to print this. All right. Now, the only part that is remaining is that when this event occurs, we have to assign this particular member. We have to add this to the delegate. The way we added it for the add function, we are going to add all these function name inside this particular member here. So the person P m1.person dot ring the bell dot this event here, ring the bell. We're going to do plus equal to and assign this function m1 dot, I'm going to have to change this to public and assign it over here like this, and change this to m2. Now when this person rings the bell, because of events, it is going to come and look at this, and because these variables are initialized to point to these functions, which is printing the name of the person who is notified. I'm going to change this to is notified. This function is going to get called for m1 and m2, and on ring bell we are going to say ring the bell, and we're going to invoke it like this, right? So when the person comes here, rings the bell, it is going to trigger this particular event in the person class, and because this is a delegate and it has been pointing for two members over here, it is going to print it twice. I hope that there are no surprises. I might have to initialize this when I'm creating person. I might see an exception. So if I go to the visitor class again, alright, I have to change this to m2 as well. And now if I run it, it is saying that m1 is notified, m2 is notified, right? So let's jump back into the code, and we're going to understand the code again. So what we have done is we have defined a delegate of type bell rang. Now delegate is a requirement if we want to handle events. What we've done is we've created three classes, one for person, one for family member, and one for the application itself. Now what the application is doing, it is creating an instance, an object of the person class. It is creating two members in the family, right? Now when this person comes and rings a bell, we want to notify these two members, right? And the way to do that, what we have already seen in the delegate addition over here, is that a delegate can be added, like over here, add, subtract, and multiply. We are going to define a new type, and that type itself is event, right? Event takes the name of the delegate, and then it says that this is the ring the bell event. When this event happens, we are supposed to invoke it based on a certain action, and that action is ringing the bell. So when the person comes and he rings the bell, we are going to see that, hey, this is an event, and there would be people who are interested in knowing that this event has occurred. That definition happens inside the member class itself. And the way it happens is it keeps a copy of the one who is going to raise the event, right? And it is going to assign a function to that thing using this syntax here. So the copy of person, the event name, and it is going to subscribe to that event. That whenever this event occurs, call this function. Right? We have done this twice for two particular members. That need not be the case. We can also inform the electricity company, and then this electricity company is going to add to electricity bill, and all we have to do is now we have to tell the electricity company E that there's a person named P1, and then P1 is going to ring a bell. So when person rings the bell, we want to add something to its bell. So person P1, okay, person P1 is just P. So we assigned it to the electricity company, And now if I run this code, there are three parties that are notified: the two members in the family and the electricity board, that they are consuming electricity. You want to add to their bill. Okay, so this is the concept of events. You start with a delegate. You define what that delegate is going to do. Based on this delegate, you're going to define the event inside the one who is going to raise it, right? And then there will be multiple classes, multiple parties who are interested in that event happening, and they are going to define a handler that when something happens, you invoke something for me, right? And when that happens, they can take an action when the person actually when the object actually raises that event. All you have to do is just you have to get a copy of that event and subscribe to it. So this is where you're subscribing to it, and when that event actually happens inside the ring bell function, everybody who has subscribed to it is going to get notified. If I comment this line out and run the application again, it is only M1 who is notified. Okay, this thing comes in extremely handy when you want to disconnect multiple applications, when you want to create classes that are disconnected and still want to do some form of message passing. And then I've told you that I'm going to teach you design patterns as well. This is a working implementation of the observer design pattern. What is happening is they are observing this particular member, and when this changes something, it is going to take an action based on that, right? So this is the observer design pattern. They are all observing this event, and when this event happens, they're getting notified, and based on their notification, they are taking actions at their end, right? So moving on, I'm going to add another class. I'm going to call it exception handling. Let's do it. And okay, so let's run. Now, when you are performing arithmetic operations, say a division, I cannot divide it by a zero, right? So a statement like this is going to fail, and the output that we're going to see is this statement here: unhandled exception, system divide by zero, attempted to divide by zero, right? This is an exception, and this is going to crash the application. Your application is going to stop executing. So statements after this code is not going to statements like this. Statements after that state, after the exception, they are not going to get executed. The way to take care of this is a C# programming construct, which is try, catch, and finally. So statements that are possibly going to generate some exception, they should be encompassed and closed into a try, catch, finally block. The way to create a try catch block is you type try and then you hit tab key twice, and then any code or the code that you think is going to throw an exception goes inside, right? So because we know that this is going to generate a divide by zero exception, we're going to put it inside the try block. Inside catch, we are going to specify what do we do in case this thing happens. So we are simply going to say can't divide by zero. And now if I run this code, I'm going to see two output: can't divide by zero. This is on the catch block, and then division operation, the statement after that, it executed. So what happened is our code, it kind of expected that something bad could happen inside this piece of code. And when that happens, we are going to handle that. And there are different hierarchy, or there's a different order in which you can check. We knew that the exception was divide by zero, so we can specify that there's going to be a divide by zero exception, right? And then if we cache this, we can also specify the exception object itself. We can receive that object inside the EX object over here. And instead of printing something generic, we can print the message of EX itself with this variable. So I'm going to hit Control F5, and the message itself is attempted to divide by zero, but then we handle that exception. Now, a catch block need not always know the exception that is going to occur. There could be other exception as well that might happen over here. Uh, so the trick is that you start with the more specific version, and then you start working towards something more generic. Right? So this time we are not going to divide by 0, we're going to change it to 10, and we are going to try to generate a new exception. Like, I'm going to declare an integer array a and assign values to it. I think 1, 2, 3, two members in it. I'm going to try to access member at location number 3. So we know that there's no third member. If I try to assign a value to it, it will throw an exception. But then we were only catching